Hello friends, welcome. Today we will study tangents and normals. So tangent, what is the tangent and what is normal? How to find its equation? Okay. So we are starting from, suppose we have a curve y is equal to fx. So this is a function, and if we have a function, then we can draw a curve of this function like this. Okay. Suppose there is a point on this curve, point P, and the coordinate of point P is x1, y1. So if a line, if we are drawing a line like this, so this is the line which is touching this curve at point P. So this line is called tangent. This line is called tangent. So we have a curve y is equal to fx, and at this curve we have a point P, and suppose a line is passing through that point P and touching this curve, then this line is called tangent to this curve at this point. Tangent to this curve at this point. So tangent is a line, and each line has a slope. So how will we find the slope of the tangent? So in tangent, to find slope, first of all we have to differentiate the y. It means we have to get dy upon dx. Now to find slope of the tangent, that is m, we will have dy upon dx, that is differential coefficient, and in this expression we will put x1 in place of x and y1 in place of y1. Then we can get the slope of the tangent at that point. So I am giving you a short example. Suppose we have to find the slope of the tangent to the curve, this curve. Suppose curve is given, and we have to find the slope of the tangent at x is equal to 2. So what is the procedure? So first of all we will find dy upon dx. So here we have dy upon dx, 3x square minus 1. Now what to do? To find the slope, we will put x is equal to 2 into this expression. It means in dy upon dx. So 3 into 2 square minus 1, and which is 11. So this is the slope of the tangent to this curve at x is equal to 2. It means, suppose if we have a curve like this, so at x is equal to 2, the slope of the tangent will be 11. So this is the procedure how to find slope. So for more questions, stay connected. Okay. So see this question. Again, we have to find the slope of the tangent to the curve. Curve is given and the point is this. Now what to notice in this question? The curve is in parametric form because x is separately a function of theta and y is also a function of theta, and the point is given in the parametric form. So we have to find the slope of the tangent. To find the slope of the tangent, the first thing you have to do, you have to find dy upon dx. And in parametric, how to find dy upon dx? First we will find dx upon d theta. Remember how to differentiate parametric function. So the differentiation of this is 3 cos square theta, and the differentiation of cos theta is minus sin theta. That is, we have minus 3a cos square theta into sin theta. Now we will find dy upon d theta. So to differentiate it, so we have a is constant, sin cube theta, which means 3 sin square theta, and the differentiation of sin theta is cos theta, and finally you have 3a sin square theta into cos theta. Now remember how to find dy upon dx in parametric form. So like this, dy upon d theta upon dx upon d theta. Now you will have to put the value of dy upon d theta. So put here this and upon minus 3a cos square theta into sin theta. Now after cancelling these terms, sin 1 with power and this, and with minus, you will have tan theta. So you have dy upon dx minus tan theta. So how to find the slope of the tangent? M. To find the slope of the tangent, you know, you have to put dy upon dx and you have to put the point into it. Whether the point is in the form of Cartesian, that is x1 minus y1, or whether in the parametric form. In this question, we have given the point in parametric form. So what is your dy upon dx? Minus tan theta, but in place of theta, what you will have to put? You will have to put pi by 4, and obviously which is 1. So this is the slope of the tangent. Now one thing you have to remember, what do you mean by normal? You know, tangent is touching the curve at point P. So this is a line touching the curve at P. This is your tangent. And what is a normal? Normal is a perpendicular line passing through the tangent at the same point. So normal is also a line which is passing through the same point, but it is perpendicular to the tangent. So tangent and normals are always perpendicular. So if you have a slope of tangent, then you can find the slope of the normal by the property that two perpendicular lines, if two perpendicular lines are having slope m1 and m2, you know the product of these two lines are the product of the slopes of two lines are -1. So if you have a slope of the tangent, then you can find slope of the normal by using this property. So 4 more questions, stay connected. Now see, in previous question we were given a curve and we were finding the slope of the tangent at the given point. So we were having curve and point, and we were able to find slope of the tangent, and later on you will come to know how to find equation of the tangent. So this is a very simple situation. A curve and a point is given. But in some question we will given a curve and slope or some situation regarding the slope, and we have to find the point. Point is not given. We have to find the point. So for these type of question, there are some possible situations. You have to understand these possible situations. So number 1, if tangent is parallel to x-axis, it is shown that there is a curve and the tangent is parallel to x-axis. Any line is parallel to x-axis is having slope 0. So obviously in this situation we have to put dy upon dx equal to 0. And if the tangent is perpendicular to x-axis, or you can say parallel to the y-axis, that is tangent is vertical, in that situation you have to put dx upon dy equal to 0. Now the question is arising, how we can get dx upon dy? Whenever you are having dy upon dx, just reciprocate it, okay, by invertendo. So you just reverse it, you will have dx upon dy, and put that dx upon dy equal to 0, then you will have point in such situation. So if the tangent is parallel to any line, suppose we have to find a point that the tangent is parallel to this line, the slope of the tangent, that is dy upon dx, and the slope of this line will be equal. That's why dy upon dx will be equal slope of the given line. Now if the tangent is passing through the origin, there are few questions, 1, 2 or 3 questions in which it is given that find the point but the tangent is passing through the origin. In that situation you have to put dy upon dx equal to y upon x. So in the last situation, if the tangent is having equal intercepts, it means on x-axis and y-axis tangent is making equal intercepts. In this situation we can put dy upon dx either 1 or -1. It is depending upon the further situation. So there are some possible situations you have to keep in your mind to solve such question in which curve and a slope or a situation is given and you have to find the point. So let's see some question on this topic. See this question. I have written these 3 questions on the situation I have just told you. In this situation we have a curve, this is, and we have to find the point, and the situation is that the tangent is parallel to x-axis. So to solve this question, first of all find dy upon dx from the question. Dy upon dx will be 3x square minus 6x minus 9. Now because it is given that the tangent is parallel to x-axis, so in this situation what we have to do? Dy upon dx is equal to 0. This implies we have to put 3x square minus 6x minus 9 is equal to 0. So on dividing by 3 we will have x square minus 2x minus 3 equal to 0. So by splitting the middle term we will have x minus 3 and x plus 1 equal to 0. By putting them separately 0 we will have x is equal to 3 and x is equal to minus 1. To find complete point we just know x is equal to 3. So what is y? So we have to put x is equal to 3 in this curve. So okay, we are putting x equal to 3 in this curve. So we will have in 27 minus 27, then minus 27 plus 7. So we will have minus 20. So at that point y is equal to minus 20, and when we are putting x is equal to minus 1 to this curve, so we will have minus 1, then minus 3, then plus 9 plus 7, 16 and minus 4, 12. So y is equal to 12. So there are 2 points 3 comma minus 20 and minus 1 comma 12. Please verify the calculation by your own. So this is the first question. Now see second question. In this question we have to again find the point on the curve is this. So what situation is given? Here the tangent is parallel to the chord joining this and this. You know how to find the slope of the chord? y2 minus y1 upon x2 minus x1. In this situation, so first of all we will find dy upon dx. So dy upon dx will be 2x minus 2. Okay. And because it is given that the slope of the tangent, you know, remember slope of the tangent is dy upon dx, and the slope of the chord 4 minus 0 upon 4 minus 2, which is equal to 2. So now we have to put dy upon dx is equal to 2, that is 2x minus 2 is equal to 2, and from here by cancelling we know x equal to 3. So if we have x is equal to 3, so put x equal to 3 in the curve, we will have y is equal to 1. So the required point is 3 comma 1. Again the same question, find the point, and it is written points. So find the points on the curve. To this curve we have to find the point at which the tangent is perpendicular to this line. So first of all differentiate the function to get dy upon dx. So you will have 2x minus 4. And then slope of this line. So slope of this line, slope of the line. You know how to find slope of the line? So minus the coefficient of x 1 and the coefficient of y is 2. So minus 1 upon 2. Now it is given that the tangent is perpendicular to the line. Now remember, if two lines are perpendicular, then m1 into m2 is equal to minus 1. So the slope of the tangent is 2x minus 4 into the slope of the line is minus 1 by 2, and their product must be minus 1. So we will have 2x minus 4 is equal to 2 and 2, and x is equal to 3. So x will be 3. Then what will be the y? So put x is equal to 3 in this curve. You will have y is equal to calculation 9 and minus 12 plus 1. So minus 2. So your point is 3 comma minus 2. So this is your point. So in next video we will study how to find the tangent, how to find the equation of the tangent and equation of the normal. So keep watching my video. Thank you very much.